Now let's talk about layer 2 forwarding. Now layer 2 is the data link layer from the OSI reference model, which we discussed in the previous lesson or slide, and it handles the addressing beneath the IP protocol stack. So we have different kinds of addresses inside a packet to perform forwarding at different layers. Now layer 2 forwarding refers to the communication that is directed between hosts within the same subnet. Now within the same subnet is written inside the brackets kind of as a conditional because we are not considering the existence of VLANs at this point. VLANs change the game a little bit, and we'll get back to that in another lesson. So for now, just think of layer 2 forwarding within the same subnet. For the layer 2 forwarding to be possible, a packet includes unique source and destination addresses. Now perhaps the most common network type on the internet, Ethernet, uses MAC addresses. MAC addresses are not the only option. There are other layer 2 protocols such as frame relay that use a completely different form of layer 2 addressing. So now let's actually look at a MAC address. So MAC address is a 48-bit address which is split in 6 octets and it's notated in hexadecimal. Now the first 3 octets, or 24 bits, are assigned to the device manufacturer, which is shortened as OUI, and it stands for Organizational Unique ID, I believe. I hope I got that correct. And then the 3 remaining octets are unique. So here I have an example of a MAC address, how it looks like. I've written it in 2 different formats because you can see both depending on what device you're looking at. So the first form is often seen when you issue ipconfig on the command line, for example, on your PC. And the second format you might see on a switch in the MAC address table, for example. So now I actually have a link for that, so you can look up the manufacturer from the MAC address. So let's take a look at that quickly. Here I have this tool, and let me copy paste the MAC address right here, and then we just do find. So it is assigned to this manufacturer, Wistron Infocom Corporation. So these first 3 octets belong to this company. And I've just Googled OUI lookup, and that's how you can find these tools. This is not the only one available. All right, let's go back to the slideshow. Now, a device listens for network traffic containing its own MAC address before processing it further up the layers. Now, this is logical, it makes sense. So if the packet or frame is not addressed to this host, it doesn't need to process it and it can discard the frame. Whereas if the frame contains its own MAC address, it realizes like, oh, hey, it's meant for me. Let me see what I can do with this and move it up the layers. So this is similar to how you pay attention to your own name. And when someone calls out your name, you know that the message is addressed to you. And then you can start processing the language and the words and figure out what was said. Now the all-F's MAC address is the broadcast MAC address, which means that it is sent to all hosts in the same subnet or the same broadcast domain, and it is processed by all of those hosts. So the device is actually listening to its own MAC address the broadcast MAC address, and there are also multicast MAC addresses, but that's a whole nother topic for another time. Now to wrap up the lesson, MAC addresses are 48 bits or 6 octets long. The first 3 octets identify the OUI, and the last 3 octets are unique to the device. Now when a device receives a packet addressed to it, whether using its own MAC address or the broadcast MAC address, it processes the packet further up the layers.